My Hello everyone. Hello G2i. So my name is Ishwaro. First of all, thanks for your practice charts. And in this video, I would like to explain how I approach this benchmark and how I arrived at my final defeat model. First of all, when I first opened the benchmark, my goal was my goal was not to immediately decide whether it was a fair or unfair. Instead of, I want to understand the engineering problem from the perspective of software engineer reviewing someone else work. But this first, I think, the first thing is I reviewed I was the visible task contract from my understanding. The task introduced TTL based fallback catch and mechanism. The main objective is to reduce repeated backend calls when the primary catch is unavailable by temporarily storing the prior values for a configurable kernel of time. The task also emphasizes that the catch should be thread safe, as well as support concurrent request efficiently and expires entire after the configured TTL and respect the respect the context cancellation behavior also. Once I understand the problem statement, like I moved on the difference of the indentation instead of leaping only at the whether the code works like offers only whether the implementation actually satisfies the requirements described in the task. So the implementation introduced a dedicated catch component called uh, function catch or FN catch. It stores catch values together with their expiration time and uses a configurable TTL rather than a hard coded URS. And also, I notice it uses primary key memorization, which means that when multiple Go routines request same key simultaneously, only one backend request is executed while the remaining callers wait for the same result. This is an important optimization because it prevents duplicate backend calls during the concurrent access. The other one is another implementation detail is I observed on is the cleanup of expiry times. Like rather than aggressively deleting everything in the background, expired entire are removed when they are accessed again. This keeps the implementation relatively simple while still preventing scale values from the being reused. As well also, I noticed that the implementation creates cloned copies of cache resources before returning them. This prevents followers from accidentally modifying shared cache updates, which is a good decision choice because cache data should remain immutable from the perspective of consumers, right? And after understanding this implementation, I review the hidden tests. This probably the most important part of the determine benchmark fairness. So the first set of tests verified normally catch behavior. They check the catch values are reused while the TTL is valid. And after that, the expired time and test gets on low back and low, the concurrent calls correctly share the same in flight request instead of creating multi backend operate. Another important area covered by the hidden test is context cancellation. These tests verify that if one caller context is cancelled while waiting for a value, the shared backend operation should also continue for other caller instead of being cancelled entirely. And this behavior matches the intent of design because a one cancelled request should not negatively affect the unreacted request that were waiting for the same that all those things. And while reviewing these tests, I compared every expectation in the original source description as well as I want to identify whether the hidden test case was validating the behavior that was never mentioned in the visible requirement. I did not find evidence of undocumented expectation. The ident test focus on exactly the behavior of this spread in the task, including TTL expiration, concurrency, memory optimization, like catch, reuse, and cancellation semantics or lookings. Finally, I reviewed analysis the evidence that accompanied the benchmark. One interesting observation was that the automated analysis initially classified the benchmark as a broken. However, I did not rely on solely on the conclusion. Instead of, I used it only as a additional information and independent compromise compared the visible requirements and the reference implementation and the hidden test case. After completing the comparison, I concluded that automated analysis did not accurately reflect the benchmark itself. The implementation, hidden tests, and the problem statement remain consistent with each other. Because of, I concluded that benchmark is fair. My reasoning is based on the three main observations. First, the visible task contract clearly defines the expected functionality. Second, the hidden test validate only document behavior rather than the including hidden requirements. Third, the referent implementation demonstrates how those document requirements, hidden requirements, all those things. Overall, I below this benchmark provides candidates with sufficient information, all those things. So, yeah, thanks for watching this video, and I appreciated the opportunity to review this benchmark, and I hope this explanation clearly demonstrates both my technical reasoning as well as how I arrived at my final decision. Yeah, thank you. Thank you. This is your Iswar Rao signing off.